Quantum entanglement. The narrator addresses the camera directly in this very coherent and very entertaining informative breakdown of an aspect of quantum physics. Good use is made of digital graphics, location photography, and available talent.
If we look at the sand, what do we see? One whole beige-colored mass, right? Now, if we look closer, we can see that this mass is actually made up of a multiplicity of tiny particles of sand that are separate from one another and yet form this whole mass. The question is, are we like these particles of sand, separate from one another and from all the objects that surround us, like the ocean, the birds, the trees, etc.? Or are we united, connected, in physical contact with one another, forming one whole physical mass that is our world? Well, quantum physics gives us an answer. We are one, connected. How is this proved? Quantum physics proved it in a demonstration that we call quantum entanglement. The demonstration consisted of bringing two electrons together. An electron is a negatively charged elementary particle that orbits the nucleus of a cell. All electrons have their own unique way of vibrating and their unique direction of spinning. Now, they should have repelled each other, since only negatives attract positives, and vice versa. But since we forcefully brought them together, the two electrons' vibrations merged and started to vibrate in unison. We call this coherence. This coherence built an energy bond between these two electrons, called a probability wave. So we separated these two electrons in space very far distances, far enough to normally break any bond, to prove that despite the distance, they were still connected. How did we prove that these two electrons stayed connected? To answer this question, we have to know two things. One, since our two electrons are in coherence, their own magnetic fields push each other and make them rotate in directions opposite to one another. Two, in quantum physics, it is only when we look at an electron that we define, measure its state, meaning the direction in which it is spinning, because otherwise it is said to be spinning in all directions at the same time. We call this superposition. So, once we have separated the two electrons, we have observed one and therefore also measured its state. We saw that it was spinning in a direction x, and we immediately deducted that the other electron was spinning in the opposite direction y. We verified that our deduction was accurate by observation. There is no empty space that can break energy bonds between particles, and therefore between us and every object in this world. Our physical world is made of electromagnetic waves of energy that are infinite. We can only see through contrast in the relative limits of the time and space of our minds. We are the ones who create our reality depending on the way we look at the world. We can surely change ourselves and our own environment for the best.